Hey everyone, in this video let's take a look at question 62 unique paths on LeetCode. This is part of our blind 75 list of LeetCode questions. Let's begin. In this question there's a robot that is in an m by n grid, and the robot is initially starting at the top left hand corner and tries to move towards the bottom right hand corner. The robot can only move down or right at any point in time, and given two integers which basically represent the rows and columns, want to return the total possible number of unique paths that the robot can take to reach the bottom right hand corner. So this is kind of hard to see, but let's maybe take a look at this one. 3 rows and then 2 columns. So looks like that's 3 rows and then 2 columns. So something like this, right? And then let me paste that in here. I'll just make this a little bit bigger. It looks like we start here. We want to get here, right? So what are the ways we can do it? Well, we can only move down and then right. So one way is right, down, and down. That's way number 1. The other way is down, down, and right. That's way number 2. The third way is down, right, and then down. That's way number 3. Now, with these types of questions that, they often ask you to find the total number of how many ways, etc., especially during a grid format, it kind of helps to understand what we can do, right? So we can basically either move in 2 directions. We can either move down or we can move to the right. Now, I want you to notice something here. What is the total amount of ways we can reach this square here? And let me actually redraw that. What is the total amount of ways we can reach this square here? What is the total amount of ways we can reach this square here? Well, if you take a look at this one, the total amount of ways we can reach this square is actually 2, right? We can go down and then right, or we could go right and then down. The total amount of ways we can reach this square is just one way. We just go straight down. And if you take a look at this, the answer is 3, right? Which is nothing but the sum of this plus this. It's the total amount of ways we can reach above plus the total amount of ways we can reach the left. So this question, basically what it boils down to is figure out how many ways we can visit the above square to the left. Why? Well, if we know the amount of ways we can visit the above square, then we just go straight down, right? That's the only way we can reach the x. So then that's just adding on to, it would just add on to this. This is considered one way, two way. If we figure out how many ways we can reach the left-hand side square, well, that's good because now we just need to go right. And that's just added on to this current way here. So then that would be this and then all the way down here. So basically all this question is really asking us to do is basically figure out how many ways can we reach the square above here and the square above here. Now, in order for us to figure out how many ways we can reach this square here, we need to figure out how many ways we can reach this square, which is on the left, which doesn't exist, and the square above here. Similarly, for us to figure out how many ways we can reach this square here, we need to figure out how many ways we can reach this square, and then this square above here. And then you can maybe think of this as a recursive approach. You can hopefully see that this is simple recursion that we are doing. If we start off over here, so let me maybe remove all of this. If we start off over here, we want to figure out how many ways we can reach this and how many ways we can reach this. But in order to figure out how many ways we can reach this, we need to figure out how many ways we can reach this and how many ways we can reach this. And then in order to figure out how many ways we can reach this, we need to figure out how many ways we can reach this and how many ways we can reach this, etc. So this keeps going. So let's maybe start with that, a recursive approach. And one of the things you want to keep track here is that if we're in a grid format, what exactly are the total number of ways? And maybe here it's better if I use this big graph here. So what exactly are the total number of ways that we can reach any of these squares and any of these squares, right? Because if we were to do it from here, for example, if we were to do it from here, then we can look up and we can look to the left. But here, we can't really look up. There's no up. Here, we can't look to the left. There's no left. So why don't we figure out what these values are and then just fill them in our recursive cases? Well, how many ways can we actually reach any of these squares? Well, it's just one, right? Because you can only go right. If we could go in all 4 directions, we might be able to do something like this, but we can't do that. We can only go right. So basically, the amount of ways you can reach any of these items in the first row or the 0th row is just 1. Similarly, the only way you can reach any of these squares down here is you just go straight down. And so this will also just be 1. So all what we have here is all of these will be 1. And now, For any of these, we can figure out how many ways can we reach here and how many ways we can reach here. We'll start off over here. So in order for us to figure out how many ways we can reach here, go over here and we'll go over here. So this will be 2. Similarly here, this will be 1 plus 2, which is 3, and etc. We'll keep going. So let's maybe start with that and see where it takes us. So in this case, I want to do my helper for recursion. And what will I pass in here? So I want to, in the recursive examples, I want to pass in my ending location, right? You always start recursion with like the biggest case. So I want to pass in this right bottom location. So here we'll pass in m minus 1 and then n minus 1. And we'll see if we need anything else, but let's just code it up right now. So this will be my helper function self. So this will be my current row. This will be my current column. Okay, so what's some of the ways we need to do? What are some of the cases we need to solve first? First of all, if row is equal to 0, column is equal to 0, then that means we're over here or we're over here. So the amount of ways we can reach this is just 1. So we'll just return 1. Let's say instead that we actually go out of bounds. Like I don't think we will go out of bounds. I actually don't think we need this case, but if row and column is less than 0, then we can just return 0. Again, I don't think we need this because we'll stop always here at the first row, but let's just add it in case. Otherwise, what do I need to do? Well, I basically need to figure out how many ways I can reach here and how many ways I can reach here. So I will return self.helper, row minus 1 call plus self.helper, row call minus 1. Row minus 1 call refers to this square. Row call minus 1 refers to this. So now let's take a look and we'll just go ahead and run our examples. And it works, and we'll go ahead and submit. And it should also work here, but obviously we're going to get a TLE because this is not a good way of doing it. But thankfully we can fix that easily with memoization. Memoization, we just add in a memo here, which is a dictionary. We're just caching our results. So what we will do here is we will do memo at, and we want to store whatever's changing, right? So the row and call is changing. So we'll do row call is equal to 1. And then I can remove this. And here I can do memo at row call is equal to 0. And then I can check if a row call is in the memo, then I will just return memo at row call. And then here again, I will store the recursive call answer row call. And then finally, I'll return memo at row call once again. So now let's take a look at this. And always forget to add in the memo call here as well. So memo, we add in here, and then we'll click submit. And I'm getting a syntax error because I guess self.helper, and I need an equals here, that's why. So let's click submit here. So this works. So this is one way of doing it. And the simpler way is simply just to use dynamic programming. So thankfully, we can just use exactly what we have here, but transform it into dynamic programming. So in dynamic programming, what we're going to do here is, here our memo is basically like a 2D array, right? So we will create a 2D array just to house the information for dynamic programming. So the 2D array will have the same size of all of this, right? It will be m by n. And the way to do 2D array in Python, so there's a way that I will have to peek in my answer because, yes, I don't like to peek in my answers, but there is the way to do it. So it will be like this. Okay, so basically rows here is m, and then calls is n. So we're creating a m by n array, and you have to do calls first and then rows second. And so basically after this, what we want to do is you basically want to one out the first row and you want to one out the first column. So to one out the first row, we will do for I in range 0 to, looks like we're looping over the columns, right? And then what we will do is dp, and then the row will be the 0th row, and the column will be I, and we'll set this to 1. And now we will row out the first column. So here, we'll do for I in range 0 to length of rows, and we'll do dp I, and then the column will be the 0th column, and we'll do 1 over here. So now, the first row and the first column are all one out. Now what we can do is we can start filling out all of these fields over here. Basically what we will do here is for I in range, we'll start at 1 and go to the rows. For j in range, 1, and we'll go to the columns because we already filled out the first row, already filled out the first column. So now we can start at the second part here, which is all of this. And all we need to do now is just this. dp at I and j is equal to dp at I minus 1, j, I'm just copying what I have here. Row is I, j is column, plus dp at I, j minus 1. And that's all we have. And so once this is all filled out, our answer will be right over here, which is return dp at m minus 1, n minus 1. And then I can comment this out, click submit, and with any luck, arrive at the correct answer. Alright, so this is how you do this question. Basically the time complexity of n by n, right? We have to go through a grid. Also space complexity, same thing, because we're storing it in a dp array. Alright, hope you enjoyed this video. Thank you.